Section 8.3 in digits is talking about the initial value, which we already know is the b value in the slope-intercept form of a line, y equals mx plus b. So just make sure that you remember that the slope is the coefficient in front of the x. Make sure that you do not include x when I ask you what the slope is. Another phrase for slope is rate of change. And then the initial value is the b value. So if you have a plus sign in front of b, the b is positive. If it's a minus sign, it's a negative. So the slope is the rate of change. And if you take a look at the diagram here in the graph, the slope is the rise over the run. So we rise 2 and we run 3. And, excuse me, the initial value is where it starts on the y-axis. So the initial value is the y-intercept, and the point is always 0 and then the y-intercept. So the x value on the y-axis is always 0. So the point 0b is the y-intercept. Let's take a look at some equations. Circle the initial value for each linear function below. So we are looking at the equation y equals mx plus b. And if it's in that form, the b value is the y-intercept. If it's not in that form, we should think about how we can arrange it. So the first one, we have y equals mx plus b. So the b value is 2, so the initial value is 2. But in the second one, we do not have y equals mx plus b, so we need to rearrange this so that the x comes first. So this is negative 3x, and this is a positive 3. So it's y equals negative 3x plus 3. So if I'm supposed to circle the initial value is 3. In the next one, it is y equals mx plus b, so my initial value is negative 2. In the last one, it's y equals mx plus b, so my initial value is 3. Alright, in this next problem, it says Josie has 1.5 cups of water in her watering can. She fills the can before watering her plants. Water flows into the watering can at a rate of 1 cup every 4 seconds. So right there, the key word being rate, you know rate is the slope. So it goes up 1 cup every 4 seconds. So the rate of change is up 1 over 4. The rate of change and the slope are the same thing, so that's 1/4. Now we could say 0.25, those are equivalent. So we could say it either way. Typically we like slopes to be in fraction form, and rates of change, it depends on the situation. The y-intercept of the line is where it crosses the y-axis, so we're looking right here. And it's hard to tell on the graph, but if we go up here, it says Josie has 1.5 cups of water in her watering can. So the y-intercept is where she starts with the water, so that's 1.5, and that's the same as the initial value. Once we have the slope and the y-intercept, it's easy to write the function rule. So remember, the general form of a line is y equals mx plus b. So now we have the equation y equals, the m is the slope, so it's 0.25 x plus 1.5. And that's the function rule. You could write that in fraction form, so it would be y equals 1/4 x plus 3/2 if you wanted to do that. On the next page, we are asked what the rate of change and initial value of the graph is. So the rate of change is the slope, and the initial value is the y-intercept. So if we are asked what the slope is, we find 2 points on the graph, and we look to see how much we go down and over. Now it's 1 square, but we need to look at the scale. So if you look here, every box is 2 units, so it's 2, 4, 6, 8. So we really went down 2, and if we look at the x-axis, each box is 1 unit, so we went down 2 and over 1. So the rate of change is down 2 over 1, which is -2. The initial value is the y-intercept, which occurs at 8. Once we have that, even though we're not asked for it here, we can easily write the equation of the line, y equals mx plus b, so it would be y equals -2x plus 8. In the next one, the linear function in the graph models the height off the ground in feet of a person riding a zip line t seconds after pushing off from the platform. How high off the ground is the platform? So we have the equation given right here, we have the graph given, and how high off the ground is the platform? Well, the platform is right here where we start, so it's the initial value, which is 100 feet. So we could look at the graph to determine that, or the initial value in the equation is the b value, so we can see that it's 100 there. And then lastly, we have the function d equals 125 plus 80n, modeling the amount of money in dollars the zipline ticket cashier has in her cash register after selling n tickets. How much money did the cashier have in the register before she sold any tickets? So we are asked really what the initial value is. Remember, the initial value is the number that does not have the variable with it. So if we rewrote this problem, it would be d equals 80n plus 125. So the initial value is the b value, and it is when the n value is 0. So the answer is that she had $125 in the register before she sold any tickets. That ends the lesson. So now we have some questions to answer on Google. So I want you to answer number 1, what is the initial value of the linear function? So you're going to do number 1 there on Google. And then I need to move this down for you. So number 2, you have the graph here. So I'm going to have on Google, I'm going to have 2A, 2B, and 2C that you will need to answer on Google. So you're finding the rate of change, the initial value, and the function rule. So write those down on your paper, and then you can put them into Google. Number 3 asks you to explain what the initial value and rate of change mean in exercise 2. So, what does the initial value mean, and what does the rate of change mean in that problem? And I will not have you do number 4 for now. So, you need to do 1, 2, and 3 on Google Forms. Write your answers on your paper, and then you can type them into Google. The bit.ly for this, bit.ly/adesso8-3. So go to that Google form, answer these questions on the Google form, and you will be all done.